In this video, we will explore how to find the intersection of a circle and a line. And please understand that this is solving a system of equations. When you have two different equations, or even two different shapes, like a circle and a line, finding the points of intersection between them is called solving a system. So for number 9, what is an x-coordinate of a point at which the line with equation y equals x minus 3 intersects the circle? So let's just find the intersection and then look at the x-coordinate. So y equals x minus 3. This is in the form y equals mx plus b. So in other words, we know that the slope is 1. Alright, because the invisible 1, the m. We know that the y-intercept is negative 3. So let's use that if we can. So if the y-intercept is negative 3, that means we can start off at negative 3, okay, which would be right here. This would be my y-intercept. Now if the slope is 1, that means if I think of it as rise over run, alright, rise over run in this case would be 1 over 1. That means up 1 and right 1. Alright, starting from my y-intercept. So I can do that. So starting from negative 3, if I go up 1, right 1, over and over again, that's where the line is going to go. Okay, so you can see very clearly what this line is doing, and you can go ahead and draw that as well. Okay. Alright, so there is our line. Now we can visualize the intersection points, which are here and here. Alright, so the solutions to this system are these 2 points. So one solution is the point 1 comma negative 2. Another solution is the point 5 comma positive 2. Alright, so these are the 2 solutions. Now for whatever reason they just asked us for an x-coordinate. So the 2 x-coordinates of course are 5 and 1. So that's what we're looking for, I guess. Okay, so I see the 1 right here, so that's going to be the answer to this very specific question. Okay, but in general, if they had asked us to solve this system consisting of the circle and this line, okay, then these 2 points themselves would be the solutions. Alright, but maybe that'll come up later. So, taking a look at number 10, solve the following systems algebraically. You must show your work for full credit. So they gave us this little graph here, but we're going to solve it without using the graph. So if you're going to solve a system algebraically, notice again we have a line and a circle. Alright, you can tell from the y equals mx plus b with nothing squared, that's a line. You see how the x is squared and the y is squared? That's a circle. So let's just use substitution. So I like to look at it this way. We have these 2 equations. We have y equals negative x plus 3. Okay, that's one equation. And then side by side with that, I've got this x squared plus y squared is equal to 9. So substitution works like this. I can take this, since y equals this, I can take this expression and put it in for y if I want to. So that's going to give me the following. Well, I'm just going to bring down my x squared unchanged. But my y squared, this is where the substitution is happening. So instead of just being y squared, the y will be replaced with negative x plus 3. Okay, so I'll be squaring that stuff. And then the rest of it. So I have equals 9. So fine. So I have x squared Now, in order to square this, I'm going to have to write it times itself. So it'll be negative x plus 3 times negative x plus 3. All right. And that's going to be equals 9. So I'm going to have my x squared. Okay, so in order to solve this, I'm going to have I'm going to do the double distributive property. So I'm going to take this negative x and I'm going to distribute that. So negative x times negative x is going to be positive x squared. A negative times a negative is a positive. X times x is x squared. Negative x times positive 3 is going to be negative 3x. Okay, now I will distribute the 3. 3 times negative x is negative 3x. 3 times 3 is 9. Okay, so that's going to equal 9. Now, just sort of combining my like terms here, I've got x squared plus x squared. That's going to give me 2x squared. All right, negative 3x minus 3x, that's going to be negative 6x. Okay, and now I've got this plus 9, but to get these constants together, I'm going to subtract 9 from both sides. But that's going to cancel out both of these, so they're gone. So that's just going to give me equals 0. So somehow I need to solve this for x. Well, the way to do that is pull out the GCF. Let's just factor out the common factor. So if I do that, I see a common factor of 2x. So I'm going to pull out that common factor of 2x. Both of these are divisible by 2 and x. To know what goes inside the parentheses, then you divide by the common factor. So I'm going to divide both of these by 2x. If I divide this, the 2's cancel out, one of the x's cancel out, I just have x. 6 divided by 2 is 3, and these x's cancel out. So this is what will be on the inside. Mentally, I'm thinking 2x times x would be 2x squared. And 2x times negative 3 would get me back to negative 6x. So it sort of checks out. Now I have to keep going from here to find my two solutions by using something called the zero product property. And that just means that I can take each of these factors and set them equal to 0. So I'll have 2x equals 0, and I'll have x minus 3 equals 0. Here, if I divide both sides by 2, that's going to give me x equals 0. And here, if I add 3 to both sides, that's going to give me x equals 3. Alright, so these are the two x values of my solution. I still need the y values that go with them. So what I recommend is making a table of values like this. Okay, so we need an x and a y. So my two x values are 0 and 3. So there's my 0 and there's my 3. Now I need the y values that go with them. So I'm going to use this little y value equation. That's why I came up here in the first place. So my y value is going to equal negative x plus 3. So in this case, that makes negative 0 plus 3, which is just 3. Negative 0 is just 0 plus 3, which is 3. If I want this y value, negative x, so that's going to be negative 3 plus 3. Negative 3 plus 3 is 0. Alright, so these are going to be my ordered pairs. So that means my final answer, or my final answers, will be 0, 3 and 3, 0. Alright, so these are the solutions to the system. Alright, number 11. When you're solving a system of conics with a circle and a line, and the discriminant of a quadratic equation is equal to 0, how many times does the line intersect the circle? Okay, so here's what they're saying. When you're dealing with a line and a circle, so if here's a circle and then we're talking about a line, there are three possibilities. Alright, one possibility is that the line intersects a circle twice. Okay, so it hits here and here. So if you're solving some equation, that means two solutions. Okay, so that's like what we got the last time, two solutions. Alright, that problem number 10 must have been something like this. But there are two other possibilities. Sometimes the line is going to only hit the circle just barely. It'll be a tangent, and it's going to only hit once. Okay, so it's possible to have only one solution. Okay, on the other hand, you can probably see where I'm going with this. It's possible for the line and the circle to not touch at all. It's possible to have no solutions. Okay, so they're talking about this word discriminant. Well, sometimes we come up with an equation and we could use the quadratic formula to solve it. We didn't have to do that on problem number 10 because we were able to just factor out the GCF. But sometimes we get something more interesting than that. Okay, sometimes, I'm just going to make this up off the top of my head. What if instead of getting this equation right here, okay, what if instead of being 2x squared minus 6x equals 0, it had been 2x squared minus 6x plus 9 equals 0. Okay? So this is a quadratic equation. We can't just factor out a GCF. There is no GCF. We would use the quadratic formula in this case. Now the quadratic formula is like this. It goes, when you have a quadratic equation, meaning we have x squared, we can find the solutions by taking the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Alright, now the a, b, and c, of course, the a is 2, the b is the negative 6, and the c is the 9. So the part that's called the discriminant is this part that's under the radical. So when they say discriminant, they're talking about what's under the radical. And we've learned something about that. Let's look at this specific case that I just made up off the top of my head and find out what the discriminant would have been. So in this case, that would make b squared. So that would make negative 6 squared minus 4 times a times c. So this would be the discriminant. Now somehow this discriminant will tell us whether we're in this situation where there's no solution, or whether we're in this situation where there's one solution, or whether we're in this situation where there's two solutions. Alright, somehow the discriminant will tell us all of that. Let's go ahead and find out what this would be. Let's see, negative 6 squared, I'm just going to put this in my calculator real quick. If you're going to do this type of thing on the calculator, got to use parentheses. So negative 6 squared minus 4, and then 2, 9, so there's 2 times 9. Okay, so my discriminant came out to be negative 36, alright, in this made up problem. Okay, so this came out to be negative 36. Now, how does that tell me whether I have one solution or two solutions or no solutions? Well, look at it. If I followed through on this problem, this negative 36 would be under this radical, okay? What I just found was that this is negative 36 right here. Now, regardless of whatever else is happening in the problem, which in this case would be opposite of b, so fine, that's positive 6, all over 2a, so 2 times 2 is 4. This would be like the rest of the problem. But I already know what's happening right now because I have a negative under the radical. All right? The square root of negative 36 is going to be imaginary. All right? Negative 36, that's going to be 6i. All right? So I got this plus or minus 6i. These are imaginary solutions. They're not real. That's what happens when you have no solution. That's what happens when there are no intersections. Okay? So it turns out that if the discriminant is negative, then that's when I'm going to have no solutions. So maybe I'll make a little scale here. So if my discriminant is negative, then we get no solution. All right? At least no real solution. Okay? Now, normally what happens is we'll get the discriminant being a positive number. So imagine that somehow this came out to be a positive 36 instead. Then what would have happened? Now, if this had been a positive 36, okay, somehow, then what would have happened? Just make a little space for myself. If this had been a positive 36, how many solutions would I have had? Well, then this would have been just a 6. So I would have had 6 plus or minus 6 over 4. And, well, look what would have happened. That would have given me two things. 6 plus 6 over 4 and 6 minus 6 over 4. Well, this is 12 over 4, which is 3. And this is 0 over 4, which is 0. So that would give me two solutions, 3 and 0. So in other words, if the discriminant is positive, then I'm going to get two solutions. Okay, so if the discriminant is positive, then I'm going to get two solutions. Okay, so in terms of my circle, I'm talking my circle and my line. No solution, remember, is like this type of a deal. And when I'm getting two solutions, I'm talking about this type of a deal. Okay, what's left? Positive, negative. What's left? What if the discriminant is 0? Let's check that out. If the discriminant were 0, all right, so imagine instead of a 36, this was a 0. Okay, what would happen then? Well, square root of 0 is just 0. So this would give me 6 plus or minus 0 over 4. Well, does this really give me two different solutions? 6 plus 0 over 4, 6 minus 0 over 4. Is this really going to be two different things? No, because 0, we would just erase it. So this would, either way, we're looking at 6 over 4. Okay, which simplifies down to 3 over 2. Okay, but this is not two solutions, all right? It's just 3 over 2. So if the discriminant is 0, you're not really adding or subtracting anything. You're really just erasing that. So you don't get your two solutions. You just get one solution. Okay, you just get 3 over 2 in this case. Okay, so back to our little chart, what we're finding is, if that's not my chart, if the discriminant is 0, you get one solution. Okay, so in terms of my circle and my line, that's the situation where the circle and the line just barely touch at one point. Okay, so again, discriminant negative, no solution. Discriminant positive, two solutions. If the discriminant is 0, one solution. Okay, so all of that was to help us understand number 11. If the discriminant is equal to 0, how many times will the line intersect the circle? Well, we just decided that that was going to be once. one solution when the discriminant is 0. Okay? Alright, so that's why the answer here is going to be B. Okay, that's going to be the end of this video because the only remaining problem is a review question. So I'll put that on its own video. So that's it for number 11. If you want to see how the review problem works, I'll meet you on the next video.